Spherical mirrors. Consider a hollow sphere as shown here. Cut a small section of it. Now, if the outer surface of this section is made reflecting and the inner surface is made non-reflecting as shown, then we call it the convex mirror. The cross-section of the convex mirror is as shown here. In ray diagrams, this will be represented as shown. If the same section of which the inner surface is made reflecting and the outer surface is made non-reflecting as shown, then we call it as a concave mirror. The cross-section of the concave mirror is as shown here. In ray diagrams, this will be represented as shown. Thus, we can consider the inner surface of a shining spoon as a concave mirror and the outer surface as a convex mirror respectively. Concave and convex mirrors are essentially the part of a sphere. Hence, concave and convex mirror are together called as spherical mirrors. Terms associated with spherical mirrors. There are several terms associated with spherical mirrors that are used to define them. The first one is pole represented by P. It is the center of curved surface on the reflecting side. For a concave mirror, the pole is here, and for a convex mirror, the pole is as shown. Second one is the center of curvature represented by C. We know that spherical mirrors are a small part of a sphere. The center of this sphere itself is the center of curvature of the mirror. Center of curvature for convex and concave mirrors are marked here. Third one is principal axis. This is the line joining the pole and center of curvature as shown here. Fourth one is the radius of curvature represented by R. It is the radius of the sphere from which the mirror is taken out. The fifth one is focus represented by F. To understand what focus is, let's go through an activity. Let's take a concave mirror and direct the reflecting surface towards the sun. The reflected light from the mirror is caught on a sheet or paper like this. On moving the sheet back and forth, we can get a bright sharp spot on the sheet. This is because all the rays coming towards the mirror is concentrated at a single point, and we can call it as a focus of the concave mirror. We can measure this using a scale, which is the focal length of the mirror. In fact, we got a real image of the sun. Why we said it is the real image? Because it is formed from the real intersection of the reflected rays. And it can be represented in a ray diagram as shown here. Here, the parallel rays are the rays from the sun which gets reflected from the mirror and passes through the single point called focus. Let us repeat the experiment using a convex mirror. Here, we will obtain the bright spot on the mirror itself. Means, it is the virtual image of the sun which we are getting. On representing this in a ray diagram, we get something similar to as shown below. Here, the light rays from the sun is reflected outwards as shown. We can imagine these reflected rays coming from a single point behind the mirror. This is the focus of the convex mirror. We can represent the focal length as shown here. And for the spherical mirrors, radius of curvature is equal to twice the focal length, that is, R is equal to 2F. Thus, focus is the midpoint between the pole and the center of curvature. Hope you understood spherical mirrors.
Thank you for watching. Download dNote to unlock the full experience. Don't miss out on the first chapter for free. Like this video and subscribe this channel for more videos and share it with your friends.